So in this question we are asked, and they are kind enough to bold it for us, which of the quantities must be zero for it to be in equilibrium? So the first thing is that equilibrium means that the forces are balanced. That means the net force, which is Ma, is zero. And that means then that the acceleration must be zero. Acceleration must be zero. So it looks like right off the bat, the choice is B. Let's see why the other answers are incorrect. If kinetic energy is 1/2 mv squared, well, for kinetic energy to be zero, that means that the velocity must be zero. And that means it must be stationary. Now, we can have particles that are stationary, like a book sitting on a table, and no horizontal forces. That's stationary. The velocity is zero. And the acceleration is zero. But if we have an object being dragged, so here's our force normal, our force of gravity, it is being dragged, and the force of friction and the force applied are equal and opposite to each other, then the net force is also zero, and the acceleration is zero. But it is also in equilibrium. So clearly then, the velocity does not have to be zero, and that's the point that they're tricking us. That is the misconception that people have. So the kinetic energy doesn't have to be zero. This has Ek. It's not zero. It's being dragged to the right at a constant velocity, but it is in equilibrium. Just as an object in free fall that has reached terminal velocity we have air resistance acting upward, equal and opposite to gravity, and we have constant velocity. That object is at equilibrium. And we call that translational equilibrium. As opposed to stationary equilibrium. So the kinetic energy does not have to be zero, the velocity does not have to be zero, and momentum, P equals mv. Notice all three of these choices, momentum and velocity and kinetic energy, are basically, they don't have to be zero. And so therefore all three of those are eliminated. And that's 172.